Ladies and gentlemen, good day. Thank you for watching my presentation. Let me introduce myself and my partners. I am Dr. Muhammad Nasir Rafiq, a researcher of Indonesian government. I work at Agency for the Assessment and Application of Technology (BPPT), Center for Agricultural Production Technology. I present this paper with my partners, Setiawan Martono, Master Science, and Ruslan Abdul Gopar, Master Science. In this opportunity, I would like to present our research paper with the title Increasing Nutrient Quality and In Vitro Digestibility of Mixed Feed Oil Palm Waste for Ruminant Feed by Solid-State Fermentation Technology. We have some keywords from this title: nutrient quality, in vitro digestibility, mixed feed oil palm waste, and solid-state fermentation technology. Local feed ingredients are widely available from industrial and agricultural waste byproduct. Palm oil cake and solid X decanter are feed ingredients from waste byproduct of palm oil processing. Palm oil cake was produced about 560 kilograms per hectare per year, and solid X decanter was produced about 4 tons per hectare per year. The other ingredients material from this industry, for example, oil palm leaf meal, midrib of oil palm leaf, and cover crop for grazing area. They have an advantage and disadvantage values: high protein, high fat, high mannan, high digestible fiber, also high very undigestible fiber, high moisture, and high anti-nutrition. Of course, the limitation need solution by using processing technology, which could be increasing nutrient quality and also reduce for the advantage values of the feed. However, cattle will adapt with this characteristic of feed. I made classification of feed ingredients from palm oil industry. Palm oil cake is classified as air-dry concentrate protein feed, while solid extractor is high moisture protein feed. The other ingredients also are classified as their physicochemical characteristics. There is a simple bioprocessing which is always used in food industry. It is solid-state fermentation technology. Solid-state fermentation technology is determined in general as the growth of microorganisms on a solid substrate such as agricultural waste byproduct. This processing is proven to be able to improve nutrient quality like protein and resulting some feed additive content like enzyme, vitamin, coloring, and antibiotics. The palm waste byproducts such as palm oil cake and solid extractor could be utilized fungi, yeast, and bacteria as fermentation agent microorganisms for the purposes of increasing protein nutrient and production of food additive in the form of enzyme and vitamin. This research used oil palm waste byproduct. Palm oil cake, I made it B as abbreviation, and solid extractor SD. The material were obtained from oil palm industrial company in Riau, Sumatra Island, Indonesia. Palm oil cake and solid X decanter were observed physically by visual observation using microscope. They still containing hard nutshell crackers in small size particle in palm oil cake and small containing in solid X decanter. Solid-state fermentation technology is applied for mixed palm oil cake and solid X decanter (BSSD). The processing started by preparing the inoculum of Rhizopus oligosporus as fermentation agents and premix. The Rhizopus oligosporus is obtained from commercial Rhizopus for food processing in Indonesia, such as tempe. Palm oil cake and solid X decanter are mixing with the Rhizopus and premix. Then it is fermented for 6 days to get good fermented mix with BSSD. 2 by 2 factorial experimental are designed. The factor 1 is combination of mix with BSSD 70-30, 50-50, and 30-70. And the factor 2 is doses of Rhizopus inoculum 0%, 0.2%, 0.4%, and 0.8%. The resulted data was analyzed using GLM procedure as a statistical analysis package for Windows. The method for proximate and fiber analyzing use the standard methodology AOAC 2012 and modified Fansus analyze using fiber analyzer Uncom technology with paper bed technique. This graph is show the relation between proximate component and Fansus fraction. This could be explained for nutrient quality of mixed feed BSSD with the different proportion and different Rhizopus oligosporus after fermentation processing. In vitro digestibility methods using paper bank technique Uncom Desi second incubator. The method has several steps: 0.25 grams substrate of fermented mixed with BSSD preparing in filter bag. Then buffer solution and rumen inoculum is mixing. Fermentation 30 hours in incubation, then analysis of NDF. The final bag weight after NDF analysis was recorded as final weight, which is values of sample was used for digestibility estimation. Rumen inoculum was obtained from cannulated cows. Cannulated cows for rumen liquid were used and individually panned indoors at Research and Application Farm Lipi Cibinong. Ruminal fluids were collected from different sites within the rumen before morning feeding at 8 a.m. Result and discussion: the effect of proportion palm oil cake and solid X decanter with different doses of Rhizopus oligosporus on proximate fraction. We found that mixed with BSSD 50-50 and 70-30 has good growth of Rhizopus oligosporus, while 30-70 mixed with BSSD was notched after 6 days fermentation. The protein was highest at mixed with BSSD 70-30, but there is a gradual increasing of protein content at BSSD 50-50 from Rhizopus oligosporus 0% to 0.4%. Contrast with mixed with 30-70 experienced a decrease in protein content as the Rhizopus oligosporus doses. The result of fiber fraction using paper bag technique Angkon technology on mixed feed BSSD also affected by solid-state fermentation technology. Highest lignin values at mixed feed BSSD 70-30 was caused by high content of palm oil cake containing nutshell crackers. However, the acid detergent fiber content was similar between proportion of mixed feed BSSD. It showed that the ADF with low content of lignin and digestible insoluble ash has nutrient potential to be used as ruminant animal feeding. Mixed feed BSSD 3070 has high nutrient quality values as proximate and fiber fraction. The proportion of mixed feed BSSD 50-50 also has low content of crude fat contained with low digestible insoluble as DIA. This is the result, the effect of proportion mixed feed palm oil cake and solid eggs decanter with different Rhizopus oligosporus on in vitro digestibility values of fermented mixed with palm oil cake and solid decanter BSSD. Mixed with palm oil cake and solid egg decanter was affected by their proportion significantly on in vitro rumen digestibility values, while doses of Rhizopus oligosporus was not significant. This increasing was caused by lower fraction that was difficult to digest in feed using palm oil waste byproduct. The other treatment experienced a decrease in the value of in vitro true dry matter disappearance (EVTDMD) with 0.8% of doses Rhizopus oligosporus. The adjustment of coefficient of NDF was highest at mixed feed BSSD 3070 was caused by lower proportion of palm oil cake containing high difficult digestible nutrients such as lignin and ADF. In vitro to dry method experience, EVTDMD of mixed feed BSSD is more than 60% for mixed feed BSSD 50-50 and 30-70. However, the mixed feed BSSD 50-50 is the optimum proportion for mixed feed from palm oil waste byproduct. For conclusion, solid-state fermentation technology in mixed with palm oil cake and solid egg decanter BSSD with combination 50-50 and Rhizopus oligosporus 0.4% is the optimum treatment because it increases nutrient quality and in vitro rumen digestibility. So, this proportion of mixed with palm oil cake and BSSD is the optimum using the oil palm waste byproduct as ruminant animal feed.